Good morning, everyone. I'm Associate Professor Chao Zhang from Shandong University. Today we'll start a new lecture called Optical Imaging. In my course, I will talk with you about 4 different parts. Part 1, Advantages of Optical Imaging. Part 2, Optical Imaging Method. Part 3, Bioluminescence Imaging and Fluorescence Imaging. Part 4, Biomedical Imaging by Near-Infrared Light. Now, let us see Part 1, Advantages of Optical Imaging. As we have learned, molecular imaging include nuclear molecular imaging, magnetic resonance imaging, ultrasound imaging, and optical imaging. Now, let's see, what is optical imaging? Optical imaging is an imaging technique. Usually describes the behavior of visible, ultraviolet, and infrared light used in imaging. Because light is an electromagnetic wave, similar phenomena occur in X-rays, microwaves, radio waves. As we all know, the electromagnetic spectrum refers to the complete range of wavelengths of electromagnetic radiation. The electromagnetic spectrum includes the following different types of radiation, from lowest energy to highest: radio, microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays. Optical imaging in vivo mainly uses bioluminescence and fluorescence technology to label cells or genes using a very sensitive optical detection instrument. We can directly and real-time observe the cell activity and gene behavior of labeling cells and genes in vivo. Compared with other imaging methods, the advantages of optical imaging include non-ionizing radiation, allows for repeated studies over time, the potential to differentiate among soft tissues and between native soft tissues and tissue labeled with either endogenous or exogenous contrast mediate. A great potential for providing specific tissue contrasts, and offers potential capabilities for studying functional and molecular level activities. So, optical imaging is very amenable to multimodal imaging, easily combinable with other imaging techniques. In the past 20 years, rapid advances and developments in biophotonics have resulted in promising new imaging techniques with broad applications in high-resolution imaging, advances in lasers that produce very short, very intense light pulses, and other like technology advances make possible the development of instruments at moderate costs. Advances in genetics and genomics spurred applications to image cellular activity, such as visualization of gene expression in real time, as well as detection of protein synthesis during biological processes. The ability to probe physiology and molecular function using optical imaging enhances diagnostic accuracy and plays a vital role in therapeutic strategy and monitoring. So, optical imaging has the advantages of no radiation, good stability of labeled compounds, and suitable for repeated imaging after a single injection in vivo, especially with the development of optical signal detectors and the successful development of new fluorescence materials with stronger tissue penetration, such as bioluminescence, it has become an important branch of molecular imaging. Okay, that is all for this part. Thank you.